lesson in Unit 4 is being able to graph a log in an exponential function. So, on page 21, an exponential function is a J-curve because it looks just like a J, whether it's going this way or this way. The thing to remember about the exponential function is where it starts to curve, it's never going to go below that point. So it's got an asymptote, just like when we talked about rationals. So if I was looking at these two examples right here, my asymptote would be here, because it never goes below that line, and here, because it never goes below that line. So its asymptote is at 0. It's never going to go below 0. Alright? So if I'm going to actually graph them, I've got to first make my t-chart. In your calculator, look at where you're starting at, look where your t-chart's ending, there's your start and end, step is always 1, so on and so forth. So when I plug 2 to the x in my calculator, you want to make sure that that x is an exponent. So 2 exponent x, not just 2 times x. So when I do that, I get 2, 5, Alright, so after I do that, I got my ordered pairs, so I'm going to plot them. Alright, and then these up here, the little decimals, I'm just going to kind of estimate where those should be. So my exponential, my J-curve, looks like that. So now we've got to be able to identify some characteristics from that graph. The first characteristic is the x-intercept. Well, if I look at that graph, it doesn't go below 0, that x-axis. So I don't have an x-intercept. Because if I draw my asymptote, my bottom of my graph, the bottom of my graph is here, at that line, at that axis. So I don't have an x-intercept, because it doesn't go below that line. It never crosses that x-axis. I do have a y-intercept, and it's going to be at 0, 1. I can look right here for it, or I can look on my t-chart at right there. Alright, the last thing we have to be able to pick out is end behavior. Where are those two ends going? So the first one is as x is approaching infinity, and infinity is out this way in terms of x. So as x is going out that way, my y values, my graph, is going up towards positive infinity. As x is going out towards negative infinity, so after I've split that y-axis in half, so now I'm looking at this chunk here of my graph. Well, it's not going to negative infinity. Y is not going down to negative infinity because it stops and curves, so it's going towards that asymptote of 0. So, one of the end behaviors for an exponential function will go to that asymptote. It won't cross it, but it's heading towards it. So it's approaching it, which is why you say with those arrows, it's approaching whatever. Alright, number 2. So this time I'm still going to start with my t-chart to get my ordered pairs. And I have remember, when you put the original function in your calculator, make sure it's 4, then the 2, then the exponent of x. So I'm going to graph them, plot my points. And I'm just going to plot what I can. So if on my t-chart, if I'd have gone above -3, like -4, -5, -6, so on and so forth, those decimals are just going to keep getting smaller and smaller and smaller and smaller. It's never going to actually give me 0, because if I tried to solve this, there is nothing that I could plug in for x to ever give me 0. Because anything raised to the x will never give you 0. So that's why you've got that asymptote for these at 0. So I'm going to go through and I'm going to highlight. There's where my graph stops. So I've got an asymptote. So now, if I look at my characteristics, my x-intercept should cross that line that I just drew. Well, because it's an asymptote, it's never going to cross it. So this graph doesn't have an x-intercept. It's got a y-intercept at 0, 4. And that's either from the graph or from the t-chart, either one. Alright, so now my end behavior. X is going out towards positive infinity here. Y is going up towards positive infinity as well. As x is going out towards negative infinity here, that y is getting really, really close to that asymptote of 0. Never touching it, but approaching it. Alright, number 3. So I'm going to put that in my calculator, get my t-chart. Plot what I can. I can only start at 0, 6. Now this one is a little bit different because it crosses that x-axis. So I do have an x-intercept. So my graph stops and starts evening out here. That's where that curve stops and starts going in a straight line. So I do have an x-intercept. It's at 2, 0. I have a y-intercept at 0, 6. Alright, now for my end behavior, as x is going out towards positive infinity this way, those y values are getting close to my asymptote at negative 2. As x is going out towards negative infinity up here, these y values are going straight up towards positive infinity. So for exponentials, one of your end behavior is going to be that asymptote. Where that graph starts straightening out is going to be an end behavior because it's approaching it. Alright, now let's look at graphing logs. Log functions resemble that shape. It's kind of a sideways J. It looks like an exponential function's been turned sideways. If you look down at example 4 on page 23, I'm still going to go through the same process. I'm going to make my t-chart, plot my points, and see where it goes. So when I plug log base 2x in my calculator, this time your t-chart starts at negative 2 and goes to 8. And you're going to get some pretty long decimals. I'm just going to round as easy as I can to the 10th place. And to graph them, I'm going to graph those nice pretty answers first and just kind of fill in. So I'm going to graph 1, 0, then I'll go to 4, 2, then I'll do 8, 3, and then I'll just kind of fill in between. Alright, if you look at that picture, the graph keeps going this way. It keeps going that way. So when you graph it, it needs to keep going in both directions this way. So the way to figure out where this part comes in is you look at that t-chart and wherever that last error is. Wherever that last error is where your asymptote is. So because exponentials and logs are related, they're both going to have asymptote. So this time your asymptote is going to run in a different direction. It's going to run straight up and down. this time, my last error is at 0, so my asymptote is at 0. So now you've got an x-intercept is at 1, 0. Oops. But you don't have a y-intercept because your y-axis is your asymptote. So none for y-intercept. Okay? Now look at how your end behavior has changed. Even how it's written, given to you, has changed. As x is approaching infinity, that y value is also going out towards infinity because it's going up. Now it says as x approaches 0, which, hello, there's your asymptote, y is going down towards negative infinity. So your end behavior for logs and exponentials has changed a little bit. One of your asymptotes is still a part of your end behavior, but it's just the given to you part. Alright, next one. So I'm going to still make a t-chart, plug that in the calculator. This time, your first error is at 1, which is here. So that's where that asymptote is. So I'm going to go to 2. I'm just going to fill in between. Now it's going to go down here. So my asymptote is at 1. So that's here. That's where my last error was. So I've got an x-intercept, but I'm going to have to kind of guesstimate where it is. It's between 1 and 2, so you can call it 1 1/2, 1 1/8, whatever you want to call it. Just kind of guesstimate where it should fall. I'm going to call it 1 1/2. Alright, because my graph doesn't go past 1, I'm still not going to have that y-intercept. In behavior, as x is going out towards positive infinity, y is going towards positive infinity. As x is going towards 1, that asymptote, y is going straight down to negative infinity. Okay? Last example. This time we've got errors all the way down to 2. And again, I'm just rounding to the nearest 10th for my t-chart. And I'm just going to fill in. And my last error comes at 2. So my asymptote is going to be at 2, and that's where my graph starts shooting straight down. And that didn't really. Alright, so again, I'm going to have to kind of guesstimate on my x-intercept, so I'm going to call it 2.5. I still don't have a y-intercept. As x is approaching positive infinity, y is also going up towards positive infinity. And as x is approaching my asymptote of 2, y is going straight down to negative infinity.